This will be part 2 of the Earth lesson. So we've identified Earth as a planet, and now let's focus on its composition. Earth is, of course, made of matter. So it's a massive object, and the mass exerts gravitational influence. But there are different kinds of matter, what we call elements. And the Earth is made of different elements. In this cutaway, we see that the inner core of the Earth is made of solid iron and nickel. Those are two elements. The outer core is liquid iron and nickel. And the mantle is composed of different elements. And the crust will be composed of yet other elements. Now, what are elements? You're probably familiar with the periodic table of the elements. Elements are substances that cannot be chemically broken down into simpler substances. They are the primary constituents of matter. And each element is distinguished by its atomic number because elements are composed of only one kind of atom. And we'll get to what atoms are in a moment. But first, the periodic table. We see all these symbols. They stand for the names of these elements. H for hydrogen, He for helium, Li for lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And we see down here the color coding. These are alkali metals, alkaline metals, transitional metals, basic metals in green. So we can kind of categorize these elements as sort of either gas at room temperature or solid at room temperature. If it's a solid, does it have properties of metals, or doesn't it have properties of metals? So we'll say more about the elements in a future lesson. Now back to the basic structure of an element. Elements are substances composed of a single kind of atom. And atoms are tiny particles of matter made up of smaller particles called protons, neutrons, and electrons. The protons and neutrons of an atom are found in the nucleus of the atom, while the electrons orbit the nucleus. And an element's identity is determined by the atom's identity, the number of protons in the nucleus. So we'll take helium, for example. So the helium atom is shown in this cartoon here. The nucleus of the atom is where you will find protons and neutrons. Protons are positively charged particles, and because they are positively charged, they will tend to repel each other, so like charges repel, and that's a force, the electromagnetic force. And so neutrons are needed to keep the protons together in the nucleus of the atom. So neutrons act like glue, holding these positively charged protons together. And surrounding the nucleus are the electrons, negatively charged particles. Now we're going to use the analogy of an orbit, like planets orbiting a star. The electrons orbit the nucleus, but we'll see that is a sort of a misleading characterization of what's really going on. So all of these different elements are made up of different kinds of atoms, and the atoms are different because of the number of protons in the nucleus of the atom. Helium atoms have 2 protons in the nucleus. Hydrogen atoms have 1, and that's the 1 at the top left corner. Helium has 2, lithium atoms have 3, beryllium has 4, etc. Let's take a closer look at that. Here we see 6 different kinds of elements and the atoms out of which they're made. Hydrogen has 1 proton in the nucleus, 1 electron. Helium, 2 protons, 2 electrons. And we're not showing the neutrons for simplicity. Lithium has 3 protons in the nucleus of the atom, 3 electrons. Carbon, the element carbon, is composed of atoms with 6 protons in the nucleus, 6 electrons orbiting. Nitrogen has 7 protons, 7 electrons. Oxygen, 8 protons, 8 electrons. And we'll define atoms that are heavier, or elements that are heavier than others, based on the number of protons. So oxygen is a heavier element than carbon because oxygen has more protons in the nucleus of the atom than carbon does. Now on the right, we have the cutaway of the Earth again, and let's take a look at the crust of the Earth. Of course, the crust of the Earth, we're familiar, is made of rocks and stuff. So what is the Earth composed of? Well, rocks are made of minerals, which are composed of different elements. And if we take a look at the pie chart here, this will give us the relative abundances of the elements. The Earth's crust is mostly oxygen, followed by silicon, then aluminum and iron and calcium and sodium, potassium, and others. So this gives us the relative abundance. So the four most abundant elements on Earth are oxygen, silicon, aluminum, and iron. We saw that the core of the Earth was composed of iron. On the periodic table, then, here are the more abundant elements: oxygen, silicon, aluminum, iron, with lesser amounts of calcium and sodium. Now let's compare the relative abundances on the Earth with the relative abundances in our body. So here are the human body, a living thing, has lots of oxygen and carbon, hydrogen and nitrogen. So notice a different distribution of elements in living things. To see them on the periodic table, we have carbon, nitrogen, oxygen, hydrogen, and calcium again there. So, first thing to note is that living things are made from ordinary elements. Oxygen and carbon and hydrogen and nitrogen are just ordinary elements. Non-living things, like the planet itself, are made of the same kinds of elements. But there is an interesting difference. Living things are carbon-rich. So, as a percentage of the material that makes up a living thing, there's much more carbon in a living thing than there is on the Earth as a whole. Now, why is carbon enriched in living things? Well, carbon is good at making complex molecules. And we'll see this in future lessons, that carbon has an atomic structure that allows it to make many chemical bonds, to make four, to be precise, 4 chemical bonds. And that means it's able to make very complex molecules like DNA, for example, or lipids, or sugars, or amino acids. Another thing to note about Earth is that it has liquid water on its surface, and liquid water is thought to be critical for life as we know it. And why is water so important? It's good at dissolving things so chemistry can happen. Now, if we look back at our solar system then and ask the question, well, which of the planets have liquid water on their surface? It turns out to be just a fraction of the planets do. Now, every star, like our sun, has what's called a habitable zone. This is an orbital distance where conditions are favorable for the existence of liquid water on the surface of the planet. Mercury is just too close to the sun for liquid water. The water would be evaporated off the planet. Earth is comfortably within this habitable zone, shown sort of between the orbits of Venus and Mars. And Mars also had liquid water in the past. So again, it looks like Earth is just right in this nice habitable zone. It's not too close or not too far away from the sun. Water can exist as a liquid on its surface, and that's important because water is the medium in which lots of important chemistry can take place. And that chemistry then, in the history of the Earth, will lead to life. So out of all the planets in the solar system, it is Earth that is covered with water. It's Earth where life emerged. So we have on this third planet from the sun carbon-based life, and it's critically dependent upon water. And so astronomers looking for life elsewhere in our galaxy are interested in planets with similar characteristics as Earth, in the habitable zone where water might exist on the surface.